Imagine a vast ocean of darkness, dotted with islands of light. One of those islands is the solar system, where the Sun, the king of stars, dominates with 99.9% of the mass. The planets, which seem so immense to us in the night sky, are mere particles next to this giant sphere of fire. Mars, Venus, Jupiter, all are insignificant compared to the vastness of the Sun. And Earth? Our home, our small ship, is almost a grain of sand beside this incandescent colossus. But can we really grasp the difference in scale between them? Can we imagine how small we are in the grand theater of the cosmos? When we look at the Sun, we see a giant that, alone, dominates and defines the solar system. All the planets, moons, asteroids, and comets are supporting actors, orbiting around the true protagonist of this story. And this is just the first scene in a much larger cosmic narrative. But have you ever stopped to think about what this really means? Let's broaden our perspective. Now imagine that we are observing Earth from space, seeing it as a small blue dot floating in the vastness. Next to it, Jupiter appears as a true titan, so large that it could swallow over 1,000 Earths. But when we place Jupiter next to the Sun, this gas giant starts to look small. The Sun is so immense that it could contain over 1,000 Jupiters within it. We are moving from planetary comparison into the stellar scale. The Sun, this vast ocean of scorching plasma, is just one star and not even the largest that exists. In the universe, there are stars so massive that they make our Sun seem like a mere grain of sand on the cosmic beach. Giants and supergiants dominate entire galaxies, radiating more energy in a single second than the Sun could emit in thousands of years. And yet, here we are, orbiting one of these modest stars. Thinking in terms of scale, size, and magnitude reveals that there is always something bigger. But it's this vastness that makes our existence so fascinating. Every planet, every star, every grain of cosmic dust plays a role in this gigantic universal symphony. And if the Sun, with all its grandeur, is just an ordinary star, what else is out there, waiting to be discovered? As we look up at the night sky filled with bright points of light that seem so distant, it's easy to forget that each of those lights is a star similar to our Sun. Some, like Sirius and Vega, are so bright that we can see them with the naked eye even from light years away. They captivate us with their steady glow, but behind that glow, an extraordinary process is at work: nuclear fusion. Inside each star, hydrogen atoms fuse to form helium, releasing a colossal amount of energy that keeps the stars burning for millions, even billions, of years. Our Sun, for example, has been burning for about 4.6 billion years and still has plenty of fuel to keep shining. But what makes stars like Sirius and Vega so fascinating is the comparison to our Sun. Sirius, the brightest star in the night sky, is about twice as massive as the Sun and emits much more light. Yet, when we look at it from such a great distance, it appears as just a point of light, while the Sun dominates our sky, providing all the energy needed for life on Earth. This difference in perception reminds us of how vast the universe is and how insignificant cosmic distances can make even the brightest stars seem. On the immense cosmic stage where stars are the main characters, some stand out not just for their brightness but for their extreme magnitude. Stars like those of the Wolf-Rayet type, true stellar titans, challenge our understanding of the universe. These stars are so massive and luminous that they seem to defy the laws of physics, burning their nuclear fuel at an astonishing rate. These colossal stars, like our 136A1, are not only enormous in terms of mass but also in their impact on the cosmos. With masses that can be hundreds of times greater than that of the Sun, they are among the heaviest stars ever discovered. To give you an idea, our 136A1 has an estimated mass of about 200 times that of the Sun. Its presence in a region of space is like a cosmic beacon, illuminating and heating everything around it, releasing stellar winds so powerful that they can sculpt gas clouds and influence the formation of new stars. These stars are at the peak of stellar power, living in a state of constant change and explosion. Yet, as gigantic as they are, their lives are incredibly short compared to smaller stars. In just a few million years, a blink of an eye in cosmic terms, these massive stars can explode as supernovas, leaving behind stunning nebulae or even black holes. The existence of such extreme stars reminds us that the universe is a place of contrasts and extremes. Where there is vastness, there is also intensity. And while the Sun may seem like the epitome of stability, these Wolf-Rayet stars are examples of how greatness can be accompanied by voracious and fleeting energy. They are the fireworks of the cosmos, shining with an almost unimaginable intensity, but for a relatively short period before they vanish, leaving a legacy that can influence generations of new stars. As stars age, they undergo spectacular transformations. After billions of years of burning hydrogen, they begin to deplete this resource. At this critical moment, the star starts a new chapter in its life, expanding to a colossal magnitude and becoming a red giant. During this phase, the core of the star collapses under its own gravity, while the outer layers expand dramatically. The star swells to hundreds of times its original size, becoming a true giant in the cosmos. The result is a star that shines with a reddish light, yet with an intense brightness that can illuminate vast regions of space. Stars like Lambda Velorum and Mira are impressive examples of this evolutionary stage. Lambda Velorum is a red giant about 200 times larger than the Sun. Mira, on the other hand, is known for its variability, changing brightness over the course of months. With a diameter about 400 times that of the Sun, Mira is a striking reminder of how dynamic and full of dramatic changes the life cycle of stars can be. This process occurs as the hydrogen in the core becomes depleted, and nuclear fusion shifts to the outer layers, causing the star to expand. It is a phase that marks the beginning of the end of the star's life, but also a period of immense splendor. In the future, our own Sun will undergo this transformation, expanding and possibly engulfing the closest planets, including Earth. These red giants are living witnesses to stellar evolution. They show us that even in the twilight of their lives, stars can achieve a surprising beauty, transforming into giants that dominate the space around them. If red giants are impressive, then red supergiants and hypergiants are true titans of the universe. These stars are monstrous, challenging what we believed was possible in terms of size and scale. Red supergiants are stars that, after expanding enormously during the red giant phase, continue to grow, reaching colossal dimensions. They are so large that if placed at the center of our solar system, their surfaces would extend beyond the orbit of Jupiter. Betelgeuse, one of the most famous red supergiants, is about 1,000 times larger than the Sun. When we observe Betelgeuse in the night sky, we see a star that is literally nearing the end of its life, yet still impresses with its magnitude. But if Betelgeuse is already gigantic, what can be said about red hypergiants? These stars elevate grandeur to an almost unimaginable level. Hypergiants are so massive and voluminous that they make supergiants seem modest in comparison. And among them all, one stands out as the largest known star, Stevenson 2-18. This red hypergiant is so colossal that if placed at the center of our solar system, its surface would extend beyond the orbit of Saturn. To put this in perspective, Stevenson 2-18 is estimated to be more than 2,000 times the diameter of the Sun. The existence of stars like Stevenson 2-18 challenges the theoretical limits of stellar size. For a long time, astronomers believed that stars this large simply couldn't exist, but the universe has shown that there is always more to discover. These stars live relatively short lives in cosmic terms, but their influence and impact are enormous. Eventually, these hypergiants will end their lives in spectacular explosions known as supernovas, spreading their elements across the cosmos and contributing to the formation of new stars and planets. Red supergiants and hypergiants remind us that in the universe, there is always something bigger, more powerful, and more surprising than we could imagine. They are the true colossi of the cosmos, challenging our understanding and fueling our curiosity about what else might be hidden in the depths of space. Just like these stars, our own limits are often much smaller than we imagine, and there is always room to expand, explore, and discover. As our journey through the cosmos comes to an end, we are invited to reflect on the complexity of the universe around us. In every corner of space, there are unfathomable mysteries and phenomena that challenge our understanding. While giant, supergiant, and hypergiant stars impress us with their size and power, there is something even more enigmatic and colossal in the universe: supermassive black holes. These titans of the universe, hidden deep within galactic centers, are entities so powerful that they defy the very notion of size. A supermassive black hole can contain the mass of millions or even billions of suns compressed into a region of space so small it challenges the imagination. Unlike stars that radiate light, black holes are voracious consumers of matter, absorbing everything that comes near, including light. At the center of our own galaxy, the Milky Way, there exists one of these cosmic giants, known as Sagittarius A star. This supermassive black hole has a mass equivalent to about 4 million suns. Although it is invisible to the naked eye, its presence is felt in the movement of the stars around it. Supermassive black holes are not just larger than stars, they represent the pinnacle of gravitational power, distorting spacetime and challenging the laws of physics as we know them. As we contemplate the existence of these invisible giants, we are reminded that the universe is full of wonders beyond what our senses can perceive. It teaches us that no matter how large something is, there is always something even larger in the depths of space. The true challenge is to keep our curiosity alive, the desire to explore and understand, because like the universe, knowledge is infinite, and there is always something new to be discovered. Subscribe to the channel now and don't miss any amazing discoveries. See you in the next video.